All right, hello, welcome to this live class where we are going to discuss contents that we have looked at from week 6, and we're going to do 6 and 7. And if we have more time, we'll touch on week 8. If not, we'll do week 8 during the week. My name is Mildred. So in week 6, we look at the different types of charts and graphs that we can use to visualize data, and we saw the different uses of the different types of charts and graph. Your pre-recorded videos and your lesson notes have that in details. We use map, we use Plotly, we use. I'm not going to touch on that, so you will go back to your pre-recorded video to look at that. And now we said we use visualization just to be able to tell stories that the ordinary eye might not be able to see, and at a glance you should know what it's talking about, but we need to have proper annotation. We need to have explanations of what we are doing. If we are looking at the mean, the standard deviation, be able to write summary of what the visual is talking about. And we can have interactive visuals also when we use Plotly, and we can be able to see whether we have misleading proportion or distorted scales, or use it to access the quality of the data also, apart from telling a story. So whenever you create a chart or visuals using data, the first thing you want to ask yourself, and it's one of the principles of storytelling, is what question is being answered. So you don't just create charts for the sake of creating charts. It's what question are you trying to answer? And the next thing you want to ask yourself is, what insight should the viewer gain from that chart? So these two questions must be at the back of your mind. And when you develop softwares, software that's the end result of that software is to be able to have real-time reports and charts and visuals that are automatically generated, you should have questions that you're trying to answer. And these questions can be in the form of reporting indicators. And when you have those indicators, your charts, your graphs, the values you select will be geared towards answering that question, or testing the hypothesis, or trying to verify if one thing causes the other thing, or if the presence of one thing causes the presence of the other, or the presence of one causes the absence of the other. And these are the things you need to ask yourself. So visualization at the back of your mind should be all about communication. It should not be just like you're decorating a report. You should communicate something. And so we said that we use different plots. We use line plots when we want to do trends over a sequence, like a time series analysis. We use bar charts when we want to compare categories, like if we want to do rankings. And then we use scatter plots when we want to look at relationships, right? And then we do that when we are doing correlation. We use pie charts for like compositions when we want to look at percentage share, and histogram when we look at distributions to look at the spread of data, and box plots for summary statistics when we want to detect outliers. We use violin plots when we want to look at the shape of the distribution, when we want to do an advanced statistics, and heat map to look at the relationship matrix to see the feature analysis, right? And then we use Plotly for interaction when we're creating dashboards. So now we'll look at the details of week 7, where we looked at exploratory data analysis. Now everything we have learned up until this time, exploratory data analysis, are key things in preparing data. Now bad data is as good as no data. It's even worse than no data, because you have misleading results and shoot yourself to the wrong direction. And so whenever we talk about all this data, we need data, but we need actually good data, clean and useful data. Once data is not clean, when data is not useful, then there's no need for the analysis. So how do we have clean and useful data? We do that through exploratory data analysis. And what you do is to investigate the data set. And when you investigate your data set, that's the first step you do. You understand the structure and the pattern of that data set. Then you look, the next thing you want to do is to detect errors, anomalies, all those, when there are null values, if you want to replace with mean, when there are outliers, if you want to average the rows, if you want to create new columns for your data. For instance, maybe you have year of birth and you just want to put everybody's age, and then you can use that to calculate from the very time of the analysis, current year, and that. If you want to look at it to test an assumption that you have, or to discover a relationship, or you want to generate a hypothesis. So before you investigate this data, when you investigate this data set, you detect a lot, you clear all the errors or anomalies you see with the outliers and the missing values and the different columns. You even clean up the different columns and see if the sheet is not a sheet you can upload, how to make it in a format that you can use. And then you will now begin to ask questions. So when we say exploratory data analysis, we want to ask questions about the data before we model the data. And so when we say data modeling, it's just like you are selecting features, and this is the core step. You see artificial intelligence, if you don't not have this foundation, you'll get lost in it. Now you see artificial intelligence, a whole hype and buzz, and you see different people with different memes of AI, and half of the world don't even know what AI really does. They think it has come to replace the thing that's supposed to help their work, but AI is supposed to boost your efficiency and replace commonality, but it cannot totally replace humans. It only makes a human more efficient. Like, if you don't know it, how will you know the AI is wrong? Sometimes if you want to use AI to write code, it will tell you code missing some steps, and if you don't even know what it's about, you copy and paste and you think you've done what you're supposed to do. So it's good that you know the foundation. And if the model is wrong, if you have to build model from scratch, how do you do that if you do not know how to do these things and just use something that is ready made? And so you need to understand Python first, then you move into, if you want to go into data analysis, whatever you need to go into. If you just want to do scripting, building models, and then you don't need to look at all those Python web application development, you need to go straight into the data analysis. Whatever you learn in Python for data science, you can decide to go into advanced Python, where you build web applications, and having a module in that web applications where you do data analysis automatically based on the data that is collected from those forms that you have. So there are different uses, and it's something that will keep growing. So by the time you know this, you have to prepare the data and do the modeling, get your features before you can actually begin to have test and train sets, and that you will use to do machine learning and migrate even to artificial intelligence. So exploratory data analysis is more about asking questions before you model the data. So you want to just know your data set before you trust it. Okay, you don't just use the data, you want to look at it, ask questions before you can trust the data and say, now I can do this. We can generate seed data like I did in the pre-recorded video, but I won't do that. I think your lesson notes, I don't think there was a lesson notes, but we have seed data in the pre-recorded video that you can copy to just generate random data to explore numerical values and look at the categorical values, relationships, and compare groups. And so those definitions, I will not touch on it. So what we'll do is to have those pre-recorded video that teaches more on the theoretical level, and then we'll do the practical. And when you go back to the pre-recorded video, it will make more sense, the theory, because now you understand. So exploratory data analysis plays this very important role in helping us to understand our data set before we even begin modeling or coming to a conclusion about the data. We are able to examine how many features are present. When we say features, we mean the columns. When we have data like this, we want to see how many features are present there, which of those features that we want to use, the data type of each of the feature, and how values are distributed. You just look at this with a naked eye. We will even look at hidden patterns. When we explore data, we will find hidden patterns. When we use things like heat map, we will look at the relationship among the variables, and we need to know this relationship when we want to build models or we want to form hypotheses. So if I want to say, does the gender of the students does it have anything to do with their grades? Now today we're going to use the NAEP data, and I will use real world data and look at real world problems. We're going to look at real world problems for week 8, 9, and 10, but for this we'll just do some data analysis with the NAEP data. NAEP is the National Assessment for Educational Progress in the United States, where they have the minimum standard scores for the key test subjects over a trend of years. The data is publicly accessible, and I will leave the link in the week 8 resource for you to know where to download for and explore. So you can get data based on the year of the test. Everything is average, so you can use it publicly. We don't have like the raw figures for us to average, so we already have the average scores. And it says the jurisdiction if you just want national public schools, or you want to have it by state, all students, or if you want it broken down by gender, by race, you can download the data anyhow and explore how to use. And so these are real world problems. Now there's a recent study that is ongoing, which is already concluded, where neurologists wants to find out, that every generation that we have, since the time that records have been kept, the students of each generation or children of each generation outperform their parents' generation. So we grow up, our children start correcting our grammar, they start teaching us things, even if we were the smartest in our time. And it keeps happening that until the Gen Z generation, where no single place, no single year from 2010 has outsmarted their parents' generation. And so why did this happen? So they need data to ask this question. So now we have formed something. There is a trend and there is a pattern. Why is it that from 2010 up until 2026. This generation has underperformed even their parents' generation, which has never happened in the history of data recording, where a generation is supposed to be more advanced than the previous. Records were collected on when digital learning was introduced, when people started using tablets. Schools are forced to use tablets to write tests, to write computer-based tests, when things were digitized, and they were able to establish a correlation between the method of teaching and advancement in technology and the decline in educational capacity. And now this will now inform policy debate, where they can debate or ban of use of devices and technology for education, or they want to keep it and be in denial. Data is publicly available for people to run the analysis and see the correlation between advancement of technology and the places where technology has been implemented fully, and how much the students grade drop more than where it is not. So the brain is wired more for interaction or patterns. So we don't write, we use tablets with punch. It doesn't work with the brain and intelligence level. As much as it looks convenient, the children development stage, it doesn't work for them. Okay? And when children learn through play and early development, they're smarter than those who just sit on the tablet, even if they're watching educational videos all day. And so research are coming out, and with time, when it becomes set on stone, and unfortunately, it took 60 years for them to establish this pattern to see. It might take 60 years for them to reverse it back. It's just going to be a whole mess where there is no generation of innovators. And so for what we are doing here, you're learning from the grassroots. A time will come where all the memory is lost. No one knows how this was created because they have tools that are there. The tools get outdated, and who builds the next generation of tools? Nobody knows the base code. While we think that life has been made easy, we are not learning the basics. When that easy life goes away, those who created it have died. They leave notes and nobody knows how to follow and how to build things. And we have learned to make life easy for ourselves. We're waiting for who is going to understand that code, build something for us to just revive code or to copy and paste. That's all we want to do, which now makes it very dangerous for the next generation. So we explore data to find out things like this, to start debate like this, to be able to say, I have a hypothesis and we want to test it. And then people will start collecting data from different places based on the hypothesis. They will collect from different regions, from different things. And while you see that it declined, did it decline in a region, amongst a group, in a state, in a country, among a particular race of people, or among a particular age group? So now people will start asking more questions because you formed the hypothesis based on what you're looking at in your data set. All right. So that's what we are going to do with exploratory data analysis. There are different types of analysis. We have the univariate analysis, where we focus on looking at a single variable and understand all its behaviors and characteristics. And what we want to achieve with that is to summarize or identify patterns within one feature at a time. And when we want to do univariate analysis, we use histogram to visualize distribution. We use box plots to detect outliers and observe the spread of the data. We use bar charts for categorical and data comparison. And then things like summary statistics, when we do mean, median, mode, variance, and standard deviation. We use that to describe the central tendency and the variability. And we're going to go into details of calculation of this. So all of this analysis, univariate, will just provide to us those foundational insights that we need to have into those variables before we can explain the relationship. Then we have bivariate analysis, where we investigate the relationship between two variables, right? And we want to look at how two things interact. We want to see if the presence of one causes the absence of the other, or the presence of one causes when one goes high, the other goes low. It has effects, it doesn't have effects, those kind of things. And we use scatter plots to visualize the relationship between two numerical values when we're doing bivariate analysis. We use correlation coefficients, like when we do the Pearson correlation, to measure the strength of the relationship. We use crosstabs or contingency tables to analyze categorical interactions. And we also use things like line graph and covariance. And we observe changes between two variables over time using line graph. And then we use that covariance to examine how those variables vary together. So when we pair with correlation, we'll have like clearer interpretation with both covariance and correlation. So when we do this bivariate analysis, identify associations that will be helpful or useful prediction for explanation. So the example I gave of a real-world problem, where we look at the data of when the school was digitized and how the scores is, we're trying to look at the association between those two. Is there any positive or negative association that will explain what is going on? All right. Then we have multivariate analysis, where we examine the relationship involving 3 or more variables, and we do that simultaneously. And when we do this, we want to have like complex interaction. So say we are doing statistical modeling and we want to have bar chart now we want to have the frequencies of a particular thing, but we want to have this frequency modeled with the gender too. We are doing more than 3 variables at a time, or 3 or more variables at a time. So we can use scatter matrix to visualize multiple relationships at once. There's something we call principal component analysis. So we do that in machine learning. I don't think we should do that in this course. Principal component analysis, we do that to reduce dimensionality. And when we get to machine learning, it's very interesting. It's statistics heavy. And then we'll do special analysis when we use maps to interpret geographic patterns, and then time series analysis to study trends and patterns across time. So all of these deeper level multivariate analysis will allow us to have deeper insight into those kind of complex data sets and into support advanced modeling. I think I've put a link of a study I did between the relationship between the brain activation map and the people with autism, right? People who are diagnosed with autism. And we can do deeper analysis on when the person began taking things like stimulants and all of that. When we look at the functional MRI, the time of the day, and we can do all those deeper insights to find out if scanning the brain or doing a functional MRI of the brain at an early age can help with early diagnosis and things like that. We can now do that to do a classification of the data after doing all of those multiple level of analysis and statistics to find out if, okay, this doesn't explain it properly, and we cannot train a model that will automatically classify brain images to say to automatically do that to just pass in the image and just tells whether this person should be flagged to assess for further data, because now the tools they have are just more behavioral than any test to measure. So those kind of things. So you think about a real world problem. You think about the kind of data you need to analyze this problem. You collect the data. If you want historical data over time, you begin to record because we want to answer this question. So let's start recording. Maybe there's no data for it. You start recording. After several years, the same thing with drugs. When they do clinical trials, they do different stages of trials. They need to have different people that volunteer and sign their life to helping the advancement of drugs and medications and stuff. They use that to write observations and side effects and everything. So they don't just mix a formula, put it in the market and use it for trial and error. It goes through that thing, first of all on rabbits and then on real humans, or mammals that closely mimics humans and then real humans. Then they classify it as what kind of drug it is and what it can harm. And so while it is good, is it good for pregnant women? Is it good for small children? They'll do different level of analysis to answer different questions before FDA or whichever drug in the country approves, with outline side effects, looking at clinical trials and outcomes. And then during the trials, they look at different effects and tune all the composition to see at what point it begins to work, and that will become the final medication and the doses. So they can now tell you that if you go higher than this dose, you have a risk of poisoning. If you go like this, what's the therapeutic index? At what dose do people start feeling well? So things like that. So you see how computer science and you understanding code will penetrate all industries. Now, the steps that we use to perform exploratory data analysis, we use pandas to clean and to manipulate data. Pandas is just easier to use most of the time. Easy to clean and manipulate the data. We use Matplotlib if we want to do some basic visualization. We use Seaborn if we want to enhance our visual plots. We use Plotly if we want to have interactive visuals. All right. So in summary, we're saying anytime you want to analyze the data, you want to understand the objective and the context. You want to have the questions. What is the goal or the research question? Okay, that's the first thing you want to ask yourself. You want to ask again, what variables exist and what do they represent? You want to ask again, what types of data are present? You want to ask, are there any limitations or quality concerns about the data that you need to handle? Are there like domain-specific constraints of the data? So you ask all these questions, and you need to have these questions to always ask. So whenever you see data, you need to ask questions before you even begin the analysis. So when you understand these questions, you will avoid any incorrect assumption, and planning for analysis will be more effective. When you have finished understanding the data and the problem, you need to now import that data, and then we inspect. So whenever we import the data with pandas and we print out the head to see the columns, inspect them. And when we inspect, sometimes we even do the summary statistics and all of that. So importing and inspecting involves loading the data, checking the size and the structure of the data set, identify all the missing values, verify the different data types that they have, detect all the inconsistencies or anomalies, outliers, and then this will now prepare this data for cleaning and all the exploration you want to do. You can do data re-engineering, where because what the columns that are present, you use that to create new features, and that's what we call data re-engineering. So we can handle the missing data, because that is one of the things that must be addressed carefully to avoid bias. All right. And so when you determine the missing data patterns, you will decide whether to remove or impute missing values. You will apply appropriate imputation techniques. If you want to use the mean, you want to use regression or any machine learning based methods. You want to evaluate how the missing data will affect your final conclusion. So whenever you handle all of this properly, then your outcome can be more reliable, because you need to document this as you go. So whenever they want to accept your conclusion from your hypothesis, there have to be steps. What questions did you ask? How was the quality of the data? These are the things they will ask. And so sometimes they cancel clinical trials because of quality violation. So if they say that you're trying this, we're doing a clinical trial, this particular person should not be involved, or they should not have this particular stuff, and you allowed it to happen, you didn't report it, or just end the trial because it has been polluted, then find out to just cancel off funding and all research on that, because at this point, it cannot be trusted. So you see how important all of those steps are. And then when you finish with all of these steps, you want to explore the different data characteristics, and this is where you want to analyze the distribution, look at the central tendencies, which is mean, median, standard deviation, variance, all of that. So you look at the central tendencies and variability to understand that data set. Okay, so you compute summary statistics to look at mean, median, and even the mode. You look at the standard deviation, you look at how skewed it is, so you look at skewness and kurtosis. Right. So all of these measures will help you to find irregularities, will guide all of the strategy you want to use for analysis. So you can't off the get-go just say, I'm going to analyze data, I'm going to use this and use that. What you want to ask these questions first and look at all of this, you explore all of this before you decide how you want to analyze the data. Now there's something we call data transformation, which we're going to do today. And that transformation will help you prepare the data for accurate modeling. So if you don't transform it, you can't even model accurately. And so we looked at that when we looked at the JSON one, when we had to normalize, and when we have embedded dictionary, a dictionary in a dictionary. So you want to do things like scaling or normalization. We looked at that in passing, but when we apply it to real world data, you understand. We look at how to encode categorical variables. We look at the mathematical transformation that we use to address skewness, and then feature creation or aggregation. So that will enhance your model performance and how interpretable it is. Now, the visualization will now reveal patterns that the statistics alone may not, or may not be able to give you. Example is when you use a frequency table and you use a bar chart for categorical data, you will be able to see patterns that you can't see with your naked eyes. When you use histograms and density plots to look at the distributions, you can't just glance and see how distributed it is, if it is left skewed or right skewed and things. All right. So this will give you deeper understanding when you visualize. And then after visualizing, you will see outliers. So that's when you can see, when you do a scatter plot, when you see one point just far different, isolated by itself, this is an outlier. An outlier will distort your analysis and it will distort your predictions. It will even affect your mean. You can't trust anything when there's outlier. So we did interquartile range, how to get that. We use the Z-score, and there are different domain-based thresholds that you can use for outliers also. So if you go to a domain medicine, there's sometimes where a particular thing is an outlier. All right. So depending on your context, your outlier may be corrected or removed or retained. And so when you handle it properly, the analytical integrity is what you can keep. So when we talk about outlier, it's not all data that you just say this is an outlier, remove. There are domain definitions of outliers. So if you say you are looking at billionaire index, for instance, and you want to get outlier, maybe one is just value is just far above. That's very easy to say this value is far above. But in the context of medicine, and somebody is extremely healthy, has nothing, that cannot be an outlier. In that domain, it's not an outlier. All right. So you always look at the domain definition of stuff before you do that. And when you now do all of this exploratory analysis, you need to have your stakeholder meetings or cross-functional team meetings where you communicate all your findings, right? You share insights clearly and effectively. People will sit down, analyze whether your thinking pattern was okay, whether there was bias in your thinking, that you have a hypothesis, but you just want it to be true. All right. So when you communicate your findings, you summarize all your objectives and the results you have. You provide context and explanations to the data, the exploration that you did. You use visualization for clarity, and you prove things. If you do summary statistics and you do visualization, you prove beyond a shadow of a doubt what you're trying to say. Okay, you highlight major insights and limitations also, and then you suggest the next steps forward. And so when you have that clear communication, you have insights that leads to your informed decision making. All right, so now we have looked at all of the steps and all of the appropriate tools for exploratory data analysis. Okay, so we know that summary statistics is the numerical kind of analysis that describes and understands the data set, and we use aggregated metrics for that. I don't know if the pre-recorded video explained this properly for you. So can somebody tell me if you understood this part from the pre-recorded video, or you want me to repeat it?
I don't mind if it's repeated. I don't think my understanding is straight.
All right. But do you think you, with all the explanation I've given you, understand exploratory data analysis?
Yes.
Okay.
Yes, yeah.
All right. So when we have summary statistics, we want to numerically describe and understand the data set, and we want to use aggregated metrics. So summary statistics will give us things like the central tendency. When we talk about central tendency, we mean the mean, the median, the mode. It will also tell us the spread of the data. We use variance and standard deviation and the range to look at the spread, and then the shape of the distribution. And the questions summary statistics will answer is what a typical value looks like. So you want to say, what does this value of this column looks like? Or how much variation exists in the spread of all of this data? Right? Are there outliers? Are there missing data? So they are the typical questions that summary statistics do. In Python, we use describe, get the mean, median, standard deviation calculations, right? And this summary statistics is usually the first step of EDA that gives you that quick snapshot of the data. Now, going back to our NAPE data, which we will use to illustrate all of this, we want to use real-world data so that you will get a better understanding. Now, there is a public data set for NAPE. I think I have it open. You can try that. Okay, that's NAPE. There's a public data set here where you can select a subject, let's say mathematics. We want to say we want for grade 8 and jurisdiction, maybe we want just national, and you enter the main data explorer. So here you can now select all the years you want. You can, the grade is there, so I want all of this. When you see this annotated one now, it means that accommodations were not permitted for this assessment. When you say accommodations, people with disabilities and all of that. Now the jurisdiction, you want to select national, and maybe you select all the states or districts, so you can filter what you want. And the variable we just want all students. You can select race, sex. So I'm showing you this if you want to download to try. And then you create reports and then you export. All right. So I already have it exported. So I wouldn't go through that process in this lesson. I already have them exported and what I want to use for this lesson. And I save this as Mass National 8. And that's what you see. So this is what it comes down to. I just selected the national public. I didn't want the state or the district or jurisdiction. We just want a basic practice for you to use. Now we say the first step is cleaning everything we said. Now we look at this Excel file. When we try to load this, we'll know that there will be a problem, right? Let's go to Python and let me try to load this for you. So before that, let's just say what it is. The National Assessment of Educational Progress, which is the NAPE. Normally you hear National Report Cards. In the US, it provides this large-scale assessment data. And we have the data for reading and mathematics performance, and we have it for grade 4, for grade 8, and for grade 12. We have the results for states and for national, a different place, whether public or public and private, or private, and all of those groups. Then there are different demographic subgroups also, and the different trends over time. Okay, so it includes time series trends, different subgroup comparison, achievement gaps. And when you always see those things like that, you want to use Matplotlib, building clear and publication-ready visuals, all this kind of stuff. All right. So when you want to compare subgroups, and I talk about subgroups, I'm talking about we have a group of race, then there are subgroups there, black versus white versus Hispanic, or things like that, male versus female. Or you want to do economically disadvantaged versus non-disadvantaged, things like that. Those are subgroups. And then you want to do proper annotation so that and when anybody looks at your visual, it gives you stuff. All right. So you want to always include your context. You highlight significant years or any peak or drop. Things like peak years for some grades or plateau where it just stays there, or decline. You want to always point an arrow to those things. And then you can use clear axis scales. So when we inspect, we know that the scale for this score. So maybe you already have the knowledge from the Ministries of Education or whatever education body that the scale of the score is 0 to 500. So you'll be able to really put your ticks, your X and Y axis. All right. So we look at this thing, and let's say we imagine grade 8 maths chart trend. We're going to use dummy data before we use this data. So one of the first things that we will do is let's use Python first of all to understand the visual with using dummy data. Then we come back to using this Excel. So now I want to activate a virtual environment, and I want to work with we want to simulate a data set that will have different years. We'll have overall score, we'll have scores of white people, scores of black people, and then let's use that. So let me say something like import matplot.pyplot as PLT, import numpy as NP, and let's import pandas as PD. So we have this. We want to simulate the data. So we'll say I'm going to turn off Copilot so that you don't have issues with this. All right. So now we can do that without Copilot disturbing us. So we have all of these imports. These are what we want to use, and we want to simulate the data set. So let me say simulate live data, and we'll say we have the years. Let's say the years is equal to, let's just have a list of years. So I'm going to do the years here. I'll start from 20, so let's say 2003, and let's do that to every 2 years. Let's say 2003, 2005. Copilot did not go off. It wants me to turn this off and start it again. All right. Can you see it properly now?
Yes.
Okay. So we have 2025, 2005. Let's do 2007. Let's do 2009, do 2011, 2013, 2015, 2017, 2019, and let's have 2022. Then we have let's say we want to simulate the scores. Let me say I'll simulate grade 8 scores, right? So now let's say overall, let me have overall scores, and this will be equal to, so I'll put 276. Let's just put scores that are as close to the Excel sheet as possible. Then we'll do from the Excel sheet. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10. Okay. And so let's do let's say white scores. So let's just have race there. And we have 285, 287, 289. So this is average, right? So this overall score is average. So 292, 293, 292, 291, 2, 4, 6, 8, 10. Okay. And let's have 260, 262, 2, 4, 6, 8, 10. Okay, so let's have all these scores as our dummy data. We want to create a data frame from this list, all right? And I'm going to call this data, and we'll do pd dot data frame, and we'll have dictionary of key is years, or let's say year, and then we'll pass in the variable years, right? Comma, we have overall, and we pass in overall scores. Then we have white, and we pass in white scores. And then we have black, pass in black scores. Okay, so we have this data frame now. We can look at the head. Let's say print data.head. So I'm going to run this, and we'll see it year, overall, white, black. So we can see it clearly. Now this works, the data frame is created. Now we created this, we didn't put missing data, outlier or anything. We just want to look at how to plot first. So we want to look at the trend line, and we want to add annotation. So I'm just going back to week 6, how we generate plots. So this is the final data that is clean. We're not looking at any outliers. Everything is in the 200s, and so no outliers, and there is no missing data. So we have 3, 5, 7, 9, 11, 13, 15, 17, we'll say 19, 2022. Okay, so we have that, because I just look at that here. So we have 19, 2022. We want to do a line plot. We do a line plot we have matplotlib as PLT. So let's say plt.figure, that's how you start. Then we want to plot the data. So what are we plotting? What is x-axis, what is y-axis? All right. So the x-axis, we want it to be the year, right? And then the y-axis, we want it to be the score, the marker. So we'll say plt.plot. And then now, what's the axis? Data, we'll get the column, which is the column key is year. And then we want for the y-axis we have data, and the overall is the name, like this. And we want the marker to just be a circle like that, so we can do marker is equal to so this is basically a line plot. But one of the practice steps, you want to put a title, you want to properly label all of those things. All right, so let's say plt dot title. So this is for annotation, and the title here is we're simulating grade 8 maths average score, and you still want to put the time range, so we'll do 2003 to 2022, let's see, like that. And we want to do for the x label, so it will be plt.x label like this, and then the x-axis we said is the year, and we want to label the y-axis, and so we want to see the scores, right? Dot y label, and we'll label this NAEP scores, and we want to make the person know that the range of score is 0 to 500. Annotation will take a lot of marks in your assignment, okay? 0 to 500 scale, and we want to have a grid, so we can say plt.grid. There are advanced annotation. You can go to the official Matplotlib documentation to see how much annotations you can do. Without all of this x label, y label, grid, it will still plot, but it will just plot a chart that if you look at, you can't even tell the story with. All right, so we want to annotate points. Okay, before we do that, let's plot this, and then we'll say all the annotations that we are creating, or the points we want to put, like the highs and the low. All right, so let's say plt.show, and I'll run this. It should put a plot. We can see all of these plots. So I hope you can all see it, right? So it put the scores. Yeah. It put the scores. We can do these ticks further to just write the year and not put all this 0.5. All right, we can annotate this even more, but I'll leave that for you to explore. So we look at this, what is the high and what is the low. So when we look at this, we see the low is in 2022, right? And the highest point here is in 2011 or so. Let's look at our data. So we come here and we say the 2022 has a low. The low is in 2022, right? And that's 273. And the high is in 2011, 283. But no, 2001, 2, 3, 4. 1, 2, 3, 4, 5. So it's in 1, 2, 3, 4, 5. Yeah, 2011, 284. So the high is at 284. The low is at 273 from what we can see. We can come here to annotate it further for it to arrow down key points. So when you're presenting, this thing presents itself already. So let's say we want to annotate the decline in 2022. I'll write it here so you know what I'm doing here. So you see why it's important to understand your data? So by the time you do summary statistics, you know the maximum and minimum already to use. You don't even need to go to the charts for you to see. So we annotate the decline, and let's say plt.annotate like this. So I didn't do this in the pre-recorded video, so I'm just going fast. So you can use the pre-recorded video and use the same data and now do all of this. So let's say we want to have the 9-point decline from 2019, because we see that its overall is 273, and it has declined by 9 points from 2019. So just write it as the title there, annotate what we're annotating, and then we want to put XY, that's the label for that arrow. We want it to write, let's say 2022. So it should actually point an arrow down 2022 and the score of 273, right? And then we also want to annotate this further and say we want the text to be lesson. I want to remove 1 from the 80s for our high point, because if we take a high point that is better, maybe we will prefer that. Okay, let's say we will do, I'm going to do this. I'm trying to think about a different thing to do. Let's say XY text is equal to, I'm going to edit the data, and then I'll put an arrow. So put arrow props, and that will be, let's use dict for the XY that we did. And I think this is it. Let me run this again and see. So okay, we have the arrow here. So why, you see the XY wants it to be long, because we know the highest point we have is 280 something. So we want this arrow to go there. But let's see, maybe we'll use 285, and I'll have to close that so it doesn't have error before I run again. So we'll have it shorter. All right, but you will see that it interrupts the heading. And what I use 2013, I put 213 here, is that we don't have, when we come here, we want it to slant somehow that it doesn't interrupt this. So all of this you get by knowing this, knowing all of this already exists. All right. So you play around with this and then you understand exactly how to do this like this. All right. So let's say 290. Let's leave it at 290. So you can continue to plot, look at your visuals and make sure that it is clear, understandable, so you can see how much it did not interrupt anything. So this arrow points at a low. So when you are presenting and this is already telling you, see, there is a decline here. There's a whole downward movement. You want to see, why did the score decline, right, between 2019 and 2022? Was this a period of COVID where people were home, there was no school? So you can see a pattern is coming. What was the event that happened at this time? We don't have a school attendance record. You might have, people log on online, and students even participating in school. The COVID affects their family. What region were they in? Was there high incidence? Because now you can see this is the period of COVID. But even before then, 2017 to 2019, there was a decline. You can see that. You want to see what happened. You've checked both socioeconomic factors, school factors, budget factors, everything. So now we're beginning to ask questions, because now this visualization is telling us, first of all, what are we looking at? We want to look at trends, high and lows. What happened in 2011 that there was a spike up? And what happens that the decline started? Why with this decline? What made 2017? What made them go up and still keep coming down and continue with the downward trends? Was there a place of plateau? Why is everything 2002, everything okay until when we get to 2010, and then we started the decline down? So these are questions we want to ask at the end. Hypothesis. And my hypothesis is that this very much decline happened during the period of COVID. So does that have anything to do with it? It's a hypothesis you are forming. You want to now prove your hypothesis right or wrong at the end of the day. Now, does it make you understand what we're trying to achieve with data analysis?
Yes.
You now ask questions.
Yes.
You said?
Yes.
Okay. So now when you go back to your pre-recorded videos, you can now look deeply at that data that we have. I didn't bother to look at outlier detection and all those cleaning because we've done it extensively already. Now this is just one analysis. We can do subgroup comparison for the black and white. I'm going to just comment this out so that we can use the code later. Let's say we want to still use the line plot and we want to compare black and white. Let me copy this, and here I'll do subgroup comparison. We want to compare the year, but now not with the overall. We want to compare the year with white, right? And let's put a label here. The label here will be white. And then we have another group, so plt.plot. We want to do black. So that's what we labeled it as, right? White, black here. We want to have black, and we'll label this as black. Then we have grade 8 math average score by race, right? And then we'll say simulated. This video is public on YouTube, so let's say simulated, so nobody will think it's a real thing. These are dummy data, okay? Simulated. And we have the year, NAEP score, all these labels, we can keep it like that. So before we annotate anything here, because we don't know what we are annotating yet, right? So I'm going to clear here, and I'm going to run this. So now we see it now. This, we have our label is equal to white, label is equal to black. Well, I've even done the colors also see. But anyway, the black is the one that is orange, and the label, the blue one, is there. All right. So we have the grid. We have, I think we're supposed to have legend. Let's put legend so that you can know what. Let's have, I think it's plt.legend. I think it's plt.legend. I'll close this and I'll run again. Okay, so now with the legend, we know that this is white and black, right? So when we look at this, we know that there is a performance gap. Although the trend remained the same with the decline, but we have a performance gap. Where the performance gap is even really wider is for 2022, like we can see here. When we come back here, we can see in 2022, 282, 256, right? There's a performance gap in everyone. I deliberately did the data like that just so that we can see a gap. We can switch it to be this white or black, it doesn't matter, or make any race superior. We just did it like that randomly. So we have pattern is exactly the same of how it goes up and down. So there definitely has to be a factor that affects this. But now we're looking by race, and we see, let's just work on the performance gap in 2022. So we'll annotate performance gap. I'm just thinking of what we'll annotate that makes sense. So let's annotate performance gap. So let's annotate 2022, let's say achievement gap, something like that. So we want to have the difference between the scores of the white and black. So let me call this gap 2022. Will now be equal to white scores. We want the last score. So we use -1 when we do that, right? And we want minus black scores, -1. We say we're just using directly the list. We don't bother to use it from the data frame. So we just use the last item on the list, but we're using 2022. Okay, so we do black score -1 like this. So it will do the difference between them, the non-figures, and then we can now annotate and let me put the F string, and I'll put the number to this gap 2022. Then I'll say a point. So how many points it is? So maybe we'll say, sorry. So we have whatever the answer is, points decline from 20, or not decline, or let's say gap. Let's say achievement gap. Okay. Then we have X, Y. We put 2022 for it's 282 for white. So we'll say 2022, 282. And then let's look at the highest point. The highest point here is we have 293, 292, 291. So we have up to 290 something. Let's make it just 300 here so that it will not interfere with anything. So why I will do 300, I will start from where does 290 end? Start from white scores 285, so 289. Let's say this is approximately 290. So let's say it's from 2007. From where 2007 is, we are looking at that, so it doesn't cover itself. So we'll say 2007. So when you do this, you can always adjust. And let's say 300. Well, once you see it like two things overlapping, you can adjust. So we'll do this, and let's close this and run it again. So now we can see an arrow down here, and we have 26 points achievement gap here, and that's for this label up here. And then we can see where there's a decline here for the white. It's the same thing for the black. We can put another annotation if we want, but this is the point. This is what we want to do. All right. So when you do this kind of annotation and you look at this visual, the first thing anybody will see is that particular point. Why is there a decline there? So use it to highlight something. We can now do bar charts for selected years, where you want to look at compare two things. Like we'll say we want to get the overall, but we want it to be aggregated by the race also. So let's do that. I'm going to do bar chart. Do you guys understand, or you want me to repeat?
I understand.
Okay.
Getting this, yeah.
Okay. So we want to do a bar chart. So let's say plt.figure, and we want to create the groups as a list. We have the groups of overall. So you see this one we're doing manually. We'll learn how to do a script that just cleans data. You can do a script that will clean your data, and so data format, everybody will look at that script and know the data format that you do to detect outliers, what you will use. So we'll look at the scripting as one of our last lessons for this course. Notice that we have just 3 more weeks of lessons and before the course ends. So we're currently supposed to be in week 8, so we'll be in week 8 by Wednesday, and so you will have 2 more weeks of lessons, and so we'll put as much as possible. A lot of these things are things that machine learning will cover, but you will not have anything for data science or like introduction to have a feel of how tough machine learning will be if we skip this stuff. Okay, so we have 2022 scores. We want to have a bar chart to put the highest point. But now we have here overall white. Let's do this for overall white and black, right? But we're not subtracting. We want the last score for 2022. So we'll say overall scores. We want the last index position. We have the white, and then we'll have the black score. All right, let's put this as a list to get the 3 scores as a list. So now your knowledge of Python will make you, there are many ways you can do this, but I'm trying to use Python list instead. But that is because I'm using simulated data. And when you import your data, you can also do the same thing. So plt.bar, we want to have a bar chart. Now you see we made it easier by putting the groups. So we can use the groups as the x-axis, and then we use the scores as that frequency for the bar, how high the bar will be for the y-axis. So now we have done that, we'll do scores. No, we want to put a group for the x. So say groups, and then we use scores 2022 for the y-axis. We can annotate, put title, and the title here is grade 8 math scores, and we just want to do 2022. And then the y-axis, we want to label this NIB score. Then we can annotate, and we want the annotation to have, we want to annotate such that we have it done automatically like a list. I don't know how to explain this. We want to annotate the values for the bar. Well, let's run this first, then we'll annotate that value. I'm trying to think about it. Let's say plt.show, and then we run this, and then we have all of that. We can see the overall, we can see the white scores and the black score. This overall is an average, so that's why it's like this. So this and this, if the white was excessively high, it's an outlier down to it affects the average, right? When you break down by race. So, but we can see here that we have the score and then for the different race here. So you see what the highest point is here. Now we said we want to annotate something. So I'm going to annotate the bar values, and I'll say, let me use a for loop. So for I, and we want to go through okay, let's have two things. Let's say for I score in enumerate. So we want to have the index position, the value, scores 2022. We want to put the text, so say plt.text. So this is how we automatically use that loop through and use that score to annotate score plus 1, and then we convert the score to a string score, and then let's center it, the HA center. I hope this even works. Let me try this first, then I'll explain it again. Okay, yeah, we have this, the highest point on top. So this is what we want to do. We're trying to loop through this. We want to get the index position 0, the value, index position 1, the value, index position 2, the value. So we say for the index position and the value there in this variable, we want to put the text as that index position, the text on the index position, and we want to add the score plus 1. Why we say score plus 1 is we need it to write it above, not on top of this. You understand? So if the score is 273, just go higher. That's the position where we put the score, and then the string score is what we want to write there. We want it to be centered on that bar chart. So that's what this means. All right, you should look at that index position. That's where the bar chart is. Go one value above the maximum score. So we go one value above the score, and then we print it properly there. So you have an idea of how we use reward data, but we simulated this. So now what we are going to do now is to use this NIB score and see what we create. And then in week 8 live class, which will be, I'll let you know if we can do that even before the videos are released on Wednesday, or we'll do that next Saturday. So let's look at this Excel sheet. Here we have this score that's downloaded for us to look at how we can import this from Excel rather than simulate data, use real world data, tell a real story. We want to look at the different years and the average score. Those are the two things that we need. We don't need the jurisdiction. We don't need all students. If I try to get this from Python with pandas, we're going to have an error because now we are looking at the sheet. We have not cleaned up this sheet for pandas to understand. We won't get an error that will stop us actually, but we'll get an error that will make us not to be able to look at the real value. Then we'll go back to clean. And this happens when you are doing scraping data from the web. You don't know in advance what you get. And so you have to investigate, clean, put them in format. When you put it in another format, you want to maybe export somewhere to have your clean data. And so that will be when we do the script part where we make a script that's automatically cleans what we want. So we'll say import pandas has PD, and we want to, before here I want to activate my virtual environment. So I'll say, so import pandas. Now I have that data here and it's .xls. So we need to pip install a different module for us to read XLS. It's not the same Excel reading. So we'll do pip install, and you're going to install XLRD like this. If you already have it in your virtual environment, it will tell you satisfied, but if not, it's going to install it. So I already have it installed. All right. So you do pip install XL like that. Once installed, we want to get the name of the file. So let me just put this as file path. And we have maths_national. That's where the file is. Underscore copy.xls like that. And then I want to load this into a data frame. So I'll say df is equal to pd dot read Excel, and we'll pass in the file path, and we'll put the name of the sheet name equal to, when we come here, the sheet name is data table, so I will go back there and put sheet name is equal to, it's all caps, data table. So we've done that. Let's see whether it will show the data. So we'll see the kind of problems we will have because we did not clean the sheet properly. So I'll run this, and you can see we have all of this in different lines printing out here. This does not tell us what the columns are, and so we don't know what this is. So this tells you that your sheet needs some cleaning. Now, what we clean here is, I just delete all of these columns. We don't need it, right? All of this to leave only the heading, right? So I delete this and make sure that I delete all of those top. Then I look at the bottom here. I know what the one means. Sorry, I delete all of this. Then I look here and I see this is supposed to be a number, but it's a string. And there is 2000, 2000. This is the ones without accommodation. So I can decide to have this and delete this value here. And then this reflects the total for 1996. I'll remove the one above so it will not be a string, and delete this one because that one has everything and the other one showed with accommodation. So this one, I remove the one here, and 1990, I remove the one here. So we have data now that is clean. Okay, we don't have any duplicates. Now, do I need this jurisdiction and this? They're all the same. So I can come here and say I want to delete these two columns too, right? So once you delete them like this, you have cleaned this data. I'll save this. So I have my year and average skills. I can even rename this to be year, and I'll rename this to be average score. So we'll have this thing cleaned out. I'll save this. I'll come back here. I'll clear here, and then I'll reload again. And now we have it, year average score. So you see why it is important to inspect your file. Does everyone understand what just happened?
No.
You don't understand?
I want to know where you were cleaning the file. Is it from the original file?
Yes, from the original file. Because you see what we had before, we had text, strings, and we don't need those things. So you clean and just leave just the columns you need. So from the original Excel file, you delete all of those columns that are not, all of those write-ups that they have there. You already understand it, okay? And then you now see this is the column you need. You want your file to be ready to import. So here we have this file. These are real life data that we downloaded from the NIV website. And so we have from 1990 to 2024 data here. So now we have this data. What do we want to do with it? Is the next thing you want to ask. So even if you have multiple sheets, you can list all the multiple sheets with so you can have pd.excel file. Okay, we'll do that in week 8 lesson. So I won't complicate this. So we clean the sheets we want to use, we rename the columns, make it easy for us. So when you first do the head of the data, you first import, look at the head, it's not what you want, you go to the raw sheet itself to try to say, okay, let me see what I will do. I'll do that. So we'll plot average score, we can plot the average score over time. We can annotate the important results, and then we can compare subgroups if we have subgroups. But this data we did not import with subgroups. I'll do that in week 8, where we'll really analyze and go down into the statistics for you to understand. So we have year and average score. So what we did with the plots, where we had the line plot of overall academic trend with the year, the average score, is just what you apply here. So what we just did a while ago is what you can now continue to do there. All right. So if I want to annotate all the biggest drop or expected point or the trend, you use the same thing that we just did recently. And so we have the same one for the race and everything, or subgroup comparison that we want to do. Now, I'm not going to go into that detail because we just did that and the data is ready for you to use. The detail I'm going to be looking at in our week 8 is what we did in week 7 when we look at the correlation, or I will just touch on that so that you understand that. Because in week 8, you're going to have your final project outline that you need to submit your deliverable 1 for the data you're going to analyze and all the things you're going to do. So we have looked at what we want to answer with summary statistics like this one. Now, if we want to do summary statistics on this, we want to look at distribution and frequency. We don't have too many data to look at here. If we use another data set, I don't know if I want to use this NIP data for, let's see, I have another NIP data here. Let me open one here. So I have another one here that has, okay, so this will make us to be able to aggregate. We have by states, we have the race. and then the average score is not here. Let me see if I have one with average score. Okay, now this one has no race. Okay, so I'll get one that has the race, household income, everything. So we can analyze properly in week 8 for you to see. So you can now cluster by state and even do more things and see the average score, what state is performing, what are the factors in that state that makes it even better. Okay, so we'll do by state. I will look for more expansive data that will be more complicated. So I will explain week 8, 9, and 10 for your final project. But for this, you can do use the describe. So if you want to get your central tendency, we can say, so we use describe in Python to do that. So I'm going to do the, hold on, tf.describe, and that's what we use in pandas, right? Oh, I didn't print. So now when we do this, the describe, and this is where we get summary statistics. You just use the describe method for pandas. We get the total count. So we're doing a 15-year count, so we can see that, right? The total count is 15, and the mean, we have the mean year. So when we do all of this describe, we get the total number of years, the mean of the year, the average year, 2008, which is the midpoint or something for the median. We'll get the midpoint. We learned that when mean and median are close, if you watch the recorded video, we have that details of the definitions of all of these central tendencies on what's mean and median value, mean diverse mean, what the standard deviation versus the mean means. So we have the mean year, the standard deviation, minimum year, and the maximum year. And then we look at the 50% here is like the median. So we don't need that for the year. It's the average score that we're interested in. The mean average score is 276. The standard deviation is 6.4. The minimum value is 261. The maximum value is 283. And then we have the median is 277. All right, we see that the median and the mean are actually very close. It just tells you your data is balanced, approximately balanced. All right, so have it that way. And now you can go back to your pre-recorded video and look at the definition of this analysis. All right, so we get the mean, the median, the standard deviation definition for here. This gives you a quick snapshot of the data. Then we look at the distribution and frequency analysis that help us to understand how the values are distributed, right? Which variables move together, where are the relationship between them, and that's one we want to know when we do distribution and frequency analysis, that when we have correlation, it's not equal to the causation. When you get the correlation and say this correlates with this, but the cause, what is the cause? They're not equal. It's not equal to causation. And you watch the pre-recorded video again, it tells you a lot about that. So I'm not going to go through the theoretical part of all of those stuff that we did. Then you want to understand that distribution and frequency analysis, and we know that it helps us to look at the skewness, outlier, multi, which is data will not answer because we just have the average score and the year that we have. And then we have to look at data entry issues, whether they put the score, the year as the score as the year, things like that. And when you have data collection, sometimes you say date of birth, some people will put the current year accidental and they submit. And so you look at all those issues and you use histogram to look at that. Now, when you have a histogram that is bell-shaped, like you have a bell shape, it is normally distributed. And if you have a histogram that is right skewed, like you have the curve go more on the right, it has high outliers. If you're left, low outliers there. So you see at the lower end, you have low outliers. Maybe you have somebody that scored 1 and you have most people, after 1, the next score is 50. So you have that low outlier that will pull down or makes this not to be reliable. Then we have frequency tables. This just shows the proportions, like if you want to have like a balance. If you do frequency, how many whites, how many blacks. So you want to show balance. So if the white score is higher, the average white score is higher only because they have 2 students that score high, and the black score is lower because they have 300 students that score all those average, then it's not a balanced data, right? So you want to look at that to show the balance between the race before you can even do that. And you want to see if there's a sample bias. So I cannot say I take a country in the Caribbean whose population is less than the population of people in my village alone in my country, and I want to say there is high crime rate in my country compared to that nation in the Caribbean. It does not make sense because there's a sampling bias. So that's why you do something like births per 1,000 population, or you will do something like crime per 100,000 or things like that, where they normalize the data so that we are not sampling a country of over 200 million people with a country of less than 100,000 people, and you want to compare. It's a bias sampling, all right? And if there's any kind of segmentation. So when you do that, you can also normalize frequency to get percentage distribution. We'll not look at that in details. We did this in the pre-recorded videos. We look at correlation analysis that we use to measure the strength and the direction of relationship between numerical values, and we only have average score. We don't have another. I might even use another data, not this NAEP data. I just showed you this. I might use the NAEP and use another data to do some core analysis for you to see those statistical parts in week 8. So I'm glad I've not released with 8, so I will just re-record and do something different that will explain this. So for your assignment 6, please do not submit. I'm not going to close it. If you don't understand yet, do not submit assignment 6. Any other assignments that is open should be submitted by the 3rd of March, but every assignment 6 particularly, do not submit until we establish an understanding of this topic, and you will definitely understand at the end of week 8. So when you have a correlation coefficient of +1, you have a perfect positive relationship. When you have 0, there's no relationship. -1, perfect negative. And you look at that with the simulated data that we have, that we had study hours and attendance, exam score, and the age, and you want to see if the attendance is affected by the exam score is affected by the attendance, or the exam score is affected by the age of the student, or the exam score is affected by the study hours of the student, things like that. And that's what we use to illustrate some correlation to see if there's positive relationship, if they are likely positive or they are weak positive. We can have a correlation matrix. We can use the heat map to visualize that. And then we also have crosstabs and pivot table, and we use that to look at demographic distribution when we want to look at so when we do distribution table, so we look at overall score, we want to cross tab the overall score versus the different race, right? So we look at the distribution for the race. We can do it as when we have data that we want to look at a survey or market segmentation. We do things like cross tabs, and we use pivot table also to have stuff. And we now see what groups performs better based on what we have seen, if there are performance gaps, if at the end of the day now we can form a hypothesis, like we said here, where we said that what happened between 2019 and 2022 that the grades declined so sharply. So you form a hypothesis. Your hypothesis is the COVID pandemic affected student performance in the exam. So now other scientists will begin to research to test that hypothesis. You look at every other thing. So now we're looking for health data. We're looking for regional data of which parts were heavily hit by this pandemic, lockdown, all those data now, to prove this hypothesis right or wrong. And that's where all those other advanced statistics will come in. Now, week 8, we are going to I'm going to research heavily if this data can be useful when we use other criteria apart from just year and average age, and clean them. But I will allow you to digest this video, understand this very well before we go further, and then we'll talk about the storytelling. Okay, and what is the key idea of storytelling? It's just, it's not just about analysis to find charts and plots, which I see going around, but what story are you telling? All right, so your exploratory data analysis and your visual should be about you're communicating something. So generally, your visual storytelling that you have there should turn insight into narratives, right? So when you want to tell a story, you have scatter plots that shows relationship, you have box plots that shows distribution by category, you have bar charts that compares category, all right? So the narrative framework you want to use is have a context that asks, what question are we answering? You have the evidence, and for the evidence, what does that visualization show? You have the insights that tells you what pattern exists. And then the next thing is your action. What decision should be made based on this insight? So example of storytelling, if we look at the pre-recorded video we did something about the majors, the age, the study hours they have, their score. And one of the kind of story we can tell from that is that students in computer science major, they show higher average exam score. And why is that? Maybe because the course is tougher, they study more, and that knowledge can tail down to other subjects. And maybe because computer science can help you to understand maths, because mathematics are the basic foundations that you do in your earlier years. You can have a story that you can tell that shows that computer science student major show higher average exam score, or you have your scatter plots that indicate there's a strong linkage between the study hours and the performance, or you tell a story like saying that the intervention program should focus on improving people's study habits because there's a correlation between the study hours and their score, and intervention programs will now focus on habits when you want to look in all of those measures. So if we say people in maths are getting lower score across board, people that are math major that are getting lower score in the general course that other majors are doing, you can now say for this particular group, let's encourage study habits. And where do we apply this? We can do it in healthcare, where you have infectious disease tracking and you take risk behavior information. And when you now want to look at what is the most prevalent amongst those who are positive for a particular disease or who have a particular disease, and then maybe your intervention and all of the programs will be targeted towards that risk behavior. So if we say people who use injection drugs, people who are always taking alcohol and are drunk, seem to come down with infectious diseases or sexually transmitted disease more than people who don't. So what do you want to address? Alcoholism. You want to address illegal drug use. Understand? So that now you're giving insight into what is happening. Your visuals will just show the bar and see that injection drug users are the highest risk behaviors amongst these people that tested positive for this disease. And so we can start intervention campaigns, and we are not going to focus on the disease itself, but we're going to the root, telling them campaign against alcoholism, campaign against injection drug use. Are we transmitting this? We are sharing needles, and all of those practices and things. Is our target going to be towards distributing a syringe so people have safe practices, which we know that we're doing that is encouraging illegal drugs, or we distribute condoms, let's say in the sexually transmitted disease, we want to go on the street and distribute condoms so that people that are at risk and prevalent use is the prevalent risk behavior is multiple sexual partners. So at this point, we distribute prevention strategies, right? We give for free, do something to reduce the incident. If we go to the case of the Vital Record Office and they collect people's death certificates and you see that cost of death is a particular thing. And maybe there's a high cost of death in drug overdose. So government will put campaign on clearing off the streets of drugs because that is the most prevalent death. If it's cancer, invest more money on cancer research and things like that. So you see how this actually informs how the government distributes their budget. It's cut across all areas. But before those researchers, before those renowned people that establish books and papers, write their papers, before it gets to the president's table and one scientist whose name we know that is so popular comes to sit down in those meetings and tell them that this is the problem and this is the solution we think before the government makes policy. Before it gets that, there are people who do the heavy lifting, which are the data collectors. Clean data, useful data is more important. If you don't have the data, there is no insight. And so when you ask for funding and all those things, you need data to support research. So I want to go to a donor funding agency. I want to approach the World Health Organization. I take my data from my health unit or wherever. I say, this is what I have noticed with visual and so. We need funds to launch the campaign that we can buy condoms and pregnancy prevention drugs or something and give this environment for free because we are seeing the socio-economic factor involved. These people are poor, low economic end. If you give them these free things, we want to place adverts in major news station, we want to run Facebook campaign, we need this amount of money. Then the donor will see you have data that supports your theory, that tells them that this is what campaign you want to launch. They give it their fund, you put the intervention, you bring back data again, results for trend, maybe over 3 years to see, did this intervention actually bring a decline? Is there a plateau? Is it still going upward? What about that intervention strategy makes it to fail? So when we do things about education, why is education reform not working? Why is either there are different education reform programs, but education is going on a decline? These are the questions we're going to answer in our next lesson. Does anyone have any question?
No.
All right, so I will share the recording as soon as it becomes available, and I will send an announcement on when we're going to have week 8 live class, or if we'll have an additional live class. To this, I will work on getting some data that will actually really be interesting, that we can tell a story with, but I will show you the different places to get data in the case of your final project, all right? So thank you everyone, and see you all next week.